Today we are trying paper 31, May June 2020. Find the set of values of x for which 3 to the power 1 minus 2x is less than 5. So take ln on both sides. So when taking ln on both sides, I can write ln 3 to the power 1 minus 2x less than ln 5 to the power x. When it is ln a times b, can be written as ln a plus ln b. So that's what I'm doing for that. So I'm writing ln 2 plus ln 3 to the power 1 minus 2x is less than ln 5 to the power x. Now, whenever you have power, that becomes the coefficient. So that becomes ln 2 plus plus 1 times ln 3 is ln 3 minus 2 times ln 2x times ln 3 is 2x ln 3 is less than x ln 5. I'm taking x's together, so I'm sending this term to the other side. So ln 2 plus ln 3 is less than x ln 5 plus 2x ln 3. Factorizing, so x is common in both, so I can write ln 2 plus ln 3 is less than x ln 3 plus 2 ln 3. Now 2, which is coefficient, becomes the power. So I can write ln 2 plus ln 3 is less than x ln 5 plus ln 3 squared, which is same as ln 2 plus ln 3 is less than x ln 5 plus ln 9. I'm sending this to the other side because I want x on its own. So ln 2 plus ln 3 over ln 5 plus ln 9 is less than x, which can be written as x is more than. Whenever x is on the left hand side, it becomes comfortable to identify. So it's ln. When it is addition, we can write power. We can write multiplication. Like here, multiplication became addition. So addition becomes multiplication. ln 2 times 3 over ln 5 times 9. So that can be written as x is more than ln 6 over ln. Question 2a. Expand 2 minus 3x to the power negative 2 in ascending powers of x up to and including the term in x squared, simplifying the coefficients. So first I have to write the formula. That's 1 plus x to the power n can be written as, all right, 1 plus nx n minus 1 over 2 factorial x squared n minus 1 n minus 2 over 3 factorial times x cubed and so on. I'm using this formula. So first let's change it into let's change 2 minus 3x to the power negative 2 in the form 1 plus x to the power n. So that becomes 2 1 minus, all right, so I need it plus, so minus 3 over 2 x to the power negative 2, which is same as 2 to the power negative 2 because we can give each term its own power, and 1 plus negative 3 over 2x to the power negative 2, which becomes, the negative power goes to the denominator, becomes positive power, 2 squared 1 minus 1 plus negative 3 over 2x to the power negative 2. So that's quarter, 1 over 2 squared is quarter, 1 plus nx. So that becomes 1 plus n is negative 2 times negative 3 over 2x plus n minus 1, so negative 2, negative 3 over 2 factorial x squared. So negative 3 over 2x squared, because here x is that, n is that. X is negative 3 over 2x and n is negative 2. We are done until x squared power. We just wanted up to x squared power. All right, let's try next one, next step now, and that becomes 1. So simplifying this term will give me 3x. Simplifying that term gives me 3 times 9 quarters, which is 27 over 4 x squared, and so on. Now multiplying out, so that's 1 times quarter, 1 times 3x, quarter times 3x, 3 quarters x, quarter times 27 over 4 times x squared becomes 27 over 16 x squared dash dash dash. Remember to write the condition. Modulus of x is, here it is, the term is negative 3 over 2x, so negative 3 over 2x is less than 1, which means negative 3 over 2 times modulus of x. Modulus of negative 3 over 2 times modulus of x is less than 1. So modulus of x is less than 1 times 2 over 3, because modulus of negative 3 over 2 makes it positive like this. 3 over 2 times modulus of x is less than 1. So that modulus of x is less than 2 over 3. All right. In fact, that's the second condition. Yes, state the values of x for which the expansion is invalid. So I can just write that modulus of x is less than 2 over 3. Now next question. Express the equation tan theta plus 60 equals 2 tan theta minus 60 minus theta as a quadratic equation in tan theta, and hence solve the equation for 0 degrees less than equals theta less than equals 180 degrees. So I'm starting with left hand side. Tan theta plus 60 equals 2 plus tan 60 degrees minus theta. So what I know about that is, if it is tan alpha plus beta, let me write alpha plus beta, then it is tan alpha plus tan beta over 1 minus tan alpha tan beta. Here alpha is 60, alpha is theta in fact, and beta is 60, so I'm writing that. So that's tan theta plus tan 60 over 1 minus tan theta and tan 60, 2 plus, now tan 60 minus theta, that's what I need. So here let me try again. Tan alpha minus beta can be written as tan alpha minus tan beta over 1 plus tan alpha tan beta. So let's write that. Tan 60 minus theta can be written as tan 60 minus tan theta over 1 plus tan 60 tan theta. Now I know that tan 60 is root 3. If your calculator gives you exact values, you don't have to remember. If your calculator doesn't give, then you have to remember the values. The table of values I have given to you. So tan theta plus root 3, 1 minus tan theta times root 3 equals 2 plus root 3 minus tan theta over 1 plus root 3 tan theta. Simplifying that will give me root 3 plus tan theta over 1 minus root 3 tan theta equals 2 plus root 3 minus tan theta 1 plus root 3 tan theta. Now I'm just cross multiplying the, so that becomes root 3 plus tan theta 1 minus root 3 tan theta, 2 plus, all right, I can write 2 times 1 plus root 3 tan theta plus root 3 minus tan theta over 1 plus root 3 tan theta. So that becomes root 3 plus tan theta over 1 minus root 3 tan theta, 2 plus 2 root 3 tan theta plus root 3 minus tan theta over 1 plus root 3 tan theta. Now that becomes root 3 plus tan theta over 1 minus root 3 tan theta, 2 plus root 3 plus tan theta common. So let me write like this. I'm taking these two terms together. That's 2 root 3 minus 1. All right, let me just leave it like that. Instead of writing it in the bracket, it will make it become easier when I'm not writing it in the bracket to multiply it out. 2 root 3 tan theta minus tan theta over 1 plus root 3 tan theta. Now cross multiply them. So that's root 3 plus tan theta times 1 plus root 3 tan theta equals 1 minus root 3 tan theta times 2 plus root 3 2 root 3 tan theta minus tan theta. So I'm multiplying it out, expanding it. So root 3 times 1 plus root 3 tan theta plus tan theta 1 plus root 3 tan theta. Now I'm trying this. So multiplying it out right hand side, 1 times 2 plus root 3 plus 2 root 3 tan theta minus tan theta, which is same thing, minus root 3 tan theta times 2 plus root 3 tan theta. There is 2 plus root 3 first. 2 plus root 3 plus 2 root 3 tan theta minus tan theta. Now I'm going to expand the brackets. So root 3 times 1, root 3. And root 3 times root 3 tan theta will be 3 tan theta. Plus tan theta times 1 tan theta. Plus tan theta times root 3 tan theta is root 3 tan square theta. Now multiplying out with 1, same thing. So no need to change anything. 2 plus root 3 plus 2 root 3 tan theta minus tan theta. Now multiplying out with root 3 tan theta. So root 3 tan theta times 2, 2 root 3 tan theta minus root 3 tan theta times root 3 minus. So that's now minus root 3 tan theta times 2 root 3 tan theta is minus 3 times 2, 6 tan square theta. Minus minus is plus, root 3 tan theta times tan theta, root 3 tan square theta. Let me try to cancel out the terms that I can. So that is 2 root 3 tan theta minus 2 root 3 tan theta. Anything else that I can? Root 3 tan square theta and root 3 tan square theta. They and they. Then root 3 there and root 3 there. So now I'm remained with 3 tan theta plus tan theta, 4 tan theta equals right hand side, that is 2. So I get 2. Then it is minus tan theta minus 3 tan theta. So that's minus 4 tan theta. and the last term is negative 6 tan square theta. I'm sending all the terms from right hand side to the left hand side, so that becomes 6 tan square theta. 4 tan theta minus 4 tan theta, 8 tan theta minus 2 equals 0. I got that. So now divide by 2, I get 3 tan square theta plus 4 tan theta minus 1 equals 0. That's my equation. I'm using quadratic formula. So A is 3, B is 4, and C is negative 1. So tan theta is negative B plus or minus square root of B squared minus 4AC over 2A, negative 4 plus or minus square root of 4 squared minus 4 times 3 times negative 1 over 2 times 3. So tan theta is negative 4 plus or minus square root of 16 plus 12 over 6. So tan theta is negative 4 plus or minus square root of 28 over 6. So tan theta is, alright, it is not enough space for me. Tan theta is negative 4 plus root 28 over 6, or tan theta is negative 4 minus root 28 over 6. So basic angle alpha is tan inverse negative 4 plus root 28 over 6. So alpha is 12.1 to 1 decimal place. Now since tan is positive, because square root of 28 is more than negative 4, more than 4, so that's 5 point something. So that becomes, tan makes it tan positive. So tan is positive in all S, T, C. Tan is positive there and there. That's theta, and that's 1. So that makes it 12.1 and 180 plus 12.1. But our question says between 0 to 180 only. So I will ignore the other part. I will not have 180 plus 12.1. So, or I can just write 180 plus 12.1 ignored, or I could write out of bound. Now here the tan theta is, basic angle alpha is here, both and it's negative. So I can just try. First I will take as 4 plus root 28 over 6. Remember to take alpha as always positive. So alpha is tan inverse of that, which is 57.1 to 1 decimal place. Now tan is negative, all S, T, C. Tan is negative in second and fourth quadrant. That's 180 minus theta, and that's 360 minus theta. Since we have the our values between 0 to 180, theta lies between 0 to 180, I will ignore that part. Fourth quadrant I have to ignore. So theta is 57.1. That is from 180. I have to subtract from 180 because it is in the second quadrant. Negative 180 minus 57.1, or I can write it is 360 minus 57.1 ignored or out of bound. So therefore theta is 12.1 and 180 minus 57.1 is 122.9 to 1 decimal place. That's my answer. Let's try the next one. The curve with equation e to the power 2. If you get something like that, if you try and if you don't have enough space, here you can write, please find the remaining question on additional page, and then a page number you can write, page number dash, and then there do not forget to write the question number, and then you can carry on there. Let's try the next one. The curve with the equation y equals e to the power 2x sine x plus 3 cos x has a stationary point in the interval 0 to pi. Find the x coordinate of this point, giving your answer correct to two decimal places. So I'm writing y equals e to the power 2x sine x plus 3 cos x between 0 less than equals x less than equals pi. At stationary point, dy over dx is 0. So first I have to find derivative of this, and then I have to equate it with 0. So I'm writing dy over dx is 2 e to the power 2x. E to the power 2x, d by dx of e to the power 2x is same as e to the power 2x, but the differentiation of 2x is 2. What I'm doing is, if y equals u dot v, then dy over dx is u dash v plus u v dash. Let's find like that, so it will be easier for you instead of that. So I'm writing u is e to the power 2x, u dash is 2 e to the power 2x. Then v is sine x plus 3 cos x. So v dash will be sine x is cos x, and cos x is sine x, so negative 3 sine x. So I'm using that. Let's try that. So dy over dx, u dash, so 2 e to the power 2x, v sine x plus 3 cos x plus u e to the power 2x, v dash cos x minus 3 sine x. Now simplify that. E to the power 2x is in both, so I'm just taking it common. So dy over dx, factorizing it, and I get 2 sine x plus 3 cos x plus cos x minus 3 sine x. Simplifying that, so I get dy over dx is e to the power 2x, 2 sine x plus 6 cos x plus cos x minus 3 sine x. So dy over dx is e to the power 2x, 2 sine x minus 3 sine x is negative sine x, 6 cos x plus cos x is 7 cos x. Now dy over dx is 0 at stationary point. At stationary point, dy over dx is 0. So I'm writing e to the power 2x, 7 cos x minus sine x is 0. E to the power 2x is 0. Ignored, because for no value of x, e to the power 2x will become 0, which means 7 cos x minus sine x, 7 cos x minus sine x is 0, which means 7 cos x is sine x. I'm sending sine cos to the other side, that means sine over cos, which is tan x, is 7. Now basic angle alpha is tan inverse 7. So tan inverse 7 is 1.42 dash dash, because it's in, remember to change your calculator before you calculate in radian mode, because that says it's in radian. So alpha is 1.4288 dash dash dash. So I can write it's only 0 to pi. So I have tan, which is positive. Tan is positive in first, all, STC, and third quadrant. That's theta, that's 180 plus theta. I don't have this because it is from 0 to 180 only. So I can write x is 1.43 to 3 significant figures. Now next question says, determine whether the stationary point is a maximum or minimum. So we need to calculate now d squared y over dx squared. So dy over dx we have, I'll use that. I'm writing that it out first. So dy over dx is e to the power 2x negative sine x plus 7 cos x. Again, I'm writing u is e to the power 2x. So u dash will become 2 e to the power 2x. V is negative sine x plus 7 cos x. So v dash becomes negative cos x minus 7 sine x. Remember, differentiation of sine is positive cos and cos is negative sine. So I'm writing that. So it's again u dash v plus uv dash. So d squared y over dx squared is u dash v 2 e to the power 2x v negative sine x plus 7 cos x plus u v dash. U is e to the power 2x v dash negative cos x plus minus 7 sine x. All right, now that's same as, now I can simplify that, e to the power 2x in both, so I'm factorizing it. 2 negative sine x plus 7 cos x minus cos x minus 7 sine x, which is same as e to the power 2x negative 2 sine x plus 14 cos x minus 7 sine x. So e to the power 2x negative 2 sine x minus 7 sine x is negative 9 sine x plus 14 cos x minus cos x plus 13 cos x. Now d squared y over dx squared, whether it's maximum or minimum at the point where x is the value that we found, x is 1.43. So let's calculate d squared y over dx squared at x is 1.43. E to the power 2 times 1.43 negative 9 sine 1.43 plus 13 cos 1.43. Remember, this is in radian mode. So substitute the values and use calculator. You will get negative 123.74 dash 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 less than 0. And we can say hence the stationary point is a maximum point. Question number 5 now. Find the quotient and remainder when 2x cubed minus x squared plus 6x plus 3 is divided by x squared plus 3. So I'm dividing it. So I can write 2x cubed minus x squared plus 6x plus 3 divided by x squared plus 3 can be written as x squared plus 0x plus 3. When we don't miss any term in the descending powers of x, we don't make any mistake. So you always remember that. If you don't have any term, just write 0 times that. 2x cubed divided by x squared will be 2x. 2x times x squared is 2x cubed. 2x squared times 2x times 0x is 0x squared. 2x times then 3 is 6x. Subtract, because in division we subtract. That's 0. That's negative x squared plus 0x plus 3. X squared, that's negative x squared divided by x squared. It's negative 1. So that's negative x squared plus 0x minus 3. And that becomes 0 and that's 6. So the remaining quotient is that 2x minus 1 and the remainder is that 6. Let's try part B now. Using your answer to part A, find the exact value of 2x cubed minus x squared plus 6x plus 3 divided by x squared plus 3. So we know that so we can use this previous part, quotient 2x minus 1 and remainder is 6. So we can try like that, which is same as integration of 1 to 3 2x minus 1 plus 6 over x squared plus 3 dx, which is same as 1 to 3 2x minus 1 dx plus 6 over x squared plus 3 1 to 3 dx. Let's write like that. So that's 2x minus 1 integration of 1 to 3 2x minus 1 dx plus 6 integration 1 to 3 1 over. Let's change that part into 1 plus x form. So let's try that. So that's same as 3 1 plus x squared over 3 dx, which is same as 2x squared over 2 minus x 1 to 3, and that's 6 over 3 1 to 3 1 over 1 plus x squared over 3 can be written as x over root 3 squared dx, which is same as x squared minus x 1 to 3 plus 2, and that part becomes 10 inverse x over root 3 1 to 3. Now substituting the values, I will get 3 squared minus 3 minus, now 1 squared minus 1 plus 2 10 inverse 3 over root 3 minus 10 inverse 1 over root 3. So that's 9 minus 3 6 plus 1 squared minus 1 is 0. I don't need to write. 2 times 10 inverse 3 over root 3, which is 10 inverse root 3, which is pi over 3, minus 10 inverse 1 over root 3 is pi over 6. If your calculator does not give values, exact values in radians, then you will have to remember the table of values that I have given. Remember that, please. So that's 6 plus 2 times pi over 6, 6 plus pi over 3. Let's try the next one now. Six. The diagram shows a circle with center O and radius R. The tangents to the circle at points A and B meet at T. Now from 5 we know outside the circle there is a point from where, anywhere, there is a point from where we can draw two tangents for the circle, and the length of those tangents are equal, which means AT equals BT here. That's the first thing we should remember. Now shaded region is bounded by the tangents AT and BT. So AT BT equals by the minor arc AB. The area of the shaded region is equal to the area of the circle. Show that x satisfies the equation tan x is pi plus x. So first thing I know is these two are equal, right? And then I can draw a line from the so that I can divide it into a triangle, which is a right angled triangle. So I'm drawing that right angle triangle there. That's O, X, B and T. That's R. So area of the shaded region, area of shaded region it says area of the shaded region is equal to the area of the circle. That's what I'm using. All right. Now shaded area is area of triangle. That's two triangles. So I will take 2 times area of triangles, because both triangles are identical. So I can calculate the area of one triangle times 2 will give me the area of the quadrilateral that I have here, minus area of sector. Now using this triangle, tan x is opposite over adjacent. So that's opposite and that's adjacent. So tan x is bt over r. So I can say bt equals r tan x. I should underline that. I'm highlighting it. All right. What else I need is shaded area, 2 times half AB sine C minus half r squared theta, area of the sector. 2 and 2, I can cross it out. AB sine C, which is, I can calculate that A is R, right? I can write R times R tan x. I'm using this. That's R and that's BT. So I'm calculating that I'm using that length and that length. Now R times BT is R tan x times that angle, which is 90 degree. So sine pi over 2 minus half r squared is theta. So that's r is r squared theta is 2x. All right. So that's r squared 10x minus r squared x. R squared common, factorizing it. So it's 10x minus x. Now this area is equal to the area of the circle. So I can equate that. R 10x minus x is pi r squared. Sorry, that was r squared. So can I get rid of r squared? So I write 10x minus x is pi. What I wanted is 10x on one side. So I'm keeping 10x, I'm sending x to the other side. So 10x is pi plus x shown. That's what we were supposed to show and we have managed. Let's try next one now, number B. The equation has one root in the interval 0 to half pi. Verify by calculation that this root lies between 0 and 1 and 1.4. Now that's the equation that I have. 10x is pi plus x. Always remember that. Whenever you have equation like that, and then you have to show that this root lies between this such and such values, you have to send 1 to the other side. That means either I send 10x to the other side or pi plus x to the other side. I'm sending 10x to the other side. So I'm writing fx is pi plus x minus 10x. Now f of 1 will give me pi plus 1 minus tan 1 and the value is 2.584 dash 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 more than 0. And f of 1.4 is pi plus 1.4 minus tan of 1.4, which is negative 1.25629 dash 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 less than 0. I should say the change of sign indicates that there is at least a root between x equals 1 and x equals 1.4. I'm done with that. Let's try the next one. Number C, use the iterative formula. Xn plus 1 is tan inverse pi plus xn. Here the iterative formula is given to you. But if you are supposed to make iterative formula yourself, you have to use that part. So that's 10x is pi plus x. So I would have written 10x is pi plus x. Always remember, you have to keep x on its own. So we have 2x, right? So here already, because they have said show that, so we have shown, that means 10x on one side. So iterative formula will be xn plus 1, 10 sent to the other side, 10 inverse pi plus x. You don't change anything there. So that's why that becomes now not x equals 10x minus pi. No, because they have said to show that. So they already gave you a clue what should be the iterative formula. So x is 10 inverse pi plus x. But here it's given, we are not supposed to make it. I just wanted you to know, so that in future in exams, if you have something like that, you should remember how to get the iterative formula. Let's try the next one. If there are two of the same kind of variables, to determine the root correct to 2 decimal places, give the result of each iteration to 4 decimal places. So I'm writing xn plus 1 is 10 inverse pi plus xn. First value x1, 1 plus 1.4 divided by 2, 1.2. x2, I write 10 inverse pi plus 1.2 gives me 1.3444 to 4 decimal places. That's what they say. Each iteration to 4 decimal places. The final answer should be 2 dp. x3 is 10 inverse pi plus 1.3444 and we get 1.3515. x4, 10 inverse pi plus 1.3515 and we get 1.3518. x5 now, 10 inverse pi plus 1.3518 and I get 1.3518. So I'm getting twice the same answer. So alpha is 10 inverse 1.35 to 2 decimal places. Let's shame, it should be 1.35, not 10 inverse, 1.35. I'm so sorry. Let's try the next one, number 7 now. Let fx be cos x plus 1 sin x. Show that f dash x is less than 0 for all x in the interval negative half pi to 3 over 2 pi. That means that's 0, that's negative pi over 2. So that's fourth quadrant, pi over 2, pi, and 3 pi over 2. Basically, all 4 quadrants, but we are going from the fourth quadrant first, first, second, and third. That way we are moving. All right, let's try the next one. So fx is cos x over 1 plus sin x. We know d over dx of u over v, the quotient rule, u dash v minus uv dash over v squared. So let's say what's u? U is cos x. So u dash is negative sin x. V is 1 plus sin x and v dash is cos x. I will use this. So f dash x will be u dash v, so that's negative sin x times 1 plus sin x minus uv dash. So that's cos x times cos x over 1 plus v squared, 1 plus sin x squared. Simplifying that, expanding the brackets. So that's negative sin x minus sin squared x minus cos squared x over 1 plus sin x squared. Negative sin x minus, I can write negative sign outside, so it becomes sin squared x plus cos squared x over 1 plus sin x. Now that's negative sin x. Now sin squared plus cos squared is 1 and 1 plus sin x. Now again negative 1 common for both, so it's 1 plus sin x in the numerator over 1 plus sin x, and that was squared. I have forgotten to write squared. I can get rid of 1 sin x, 1 plus sin x, so that's negative 1 over 1 plus sin x. All right, now we know negative 1 less than equals sin x less than equals 1. That means 1 plus sin x is more than 0. If I add 1 throughout, so that becomes 0 less than equals 1 plus sin x less than equals 2. That's what I get, which means 1 plus sin x is more than 0. All right, next one, f dash x is less than 0 for all x in the interval negative half pi less than x less than 3 over 2 pi. Now why did I not include less than equals 0 here? Because I got less than equals 0. But if you notice, that's negative half pi less than x less than 3 over 2 pi, right? So if I say it is less than equals 0, so sin x is 0 when, so negative 1 when it is negative 3, when it is 3 pi over 2 or negative half pi. So sin is negative 1 there, but which is not included in our range. That's why we cannot write less than equals, we just have to write less than. So I can write f dash x is less than 0 for all the x in the interval negative half pi less than x less than pi, 3 pi over 2. Let's try number B now. Find integral 1 over 6 pi to half pi fx dx. Give your answer in the simplest form, so that I can write 1 over, so I can 1 over 6 pi is pi over 6 to pi over 2 cos x over 1 plus sin x dx. Now if fx is 1 plus sin x, f dash x is cos x, so which basically this becomes integration of f dash x over fx dx, which is ln fx plus c. But I don't need c here because that's the definite integral, so I'm writing equals, okay, which is same as ln 1 plus sin x and pi over 6 to pi over 2, which is same as ln 1 plus sin pi over 2 minus ln 1 plus sin pi over 6, which is ln 1 sin pi over 2 is 1 minus ln sin pi over 6 is half, so that's 1 plus half, so that's ln 2 minus ln 3 over 2. Division means subtraction means division, division means subtraction, so that's ln 2 over 3 over 2, which is ln 4 over 3. Let's try the next question now. Number 8 now. A certain curve is such that its gradient at a point xy is proportional to y over x root x. The curve passes through the point with coordinates 1, 1 and 4e. By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. So first of all, it is given dy over dx. Gradient at a point, that means dy over dx, at x and y is proportional to y over x root x. So I can write dy over dx is k y over x root x. It passes through 2 points. It says 1, 1 and 4e. So 1, 1 and 4e. Alright, so first I'm writing integration of setting up the differential equation. So I'm bringing the like terms together. That can be written as dy over dx is k y over x to the power 3 over 2. That will make it easier for me to work out. So instead of that, I'm highlighting that part. All right. So I'm writing y 1 over y dy is k, then 1 over x to the power 3 over 2 dx. So I'm writing integration 1 over y dy equals k integration x to the power negative 3 over 2 dx. Now integration of 1 over y is ln y equals k x to the power negative 3 over 2, integrate that. So x to the power negative 3 over 2 plus 1 will make x to the power negative half over negative half plus c. So that's ln y is negative 2k x to the power negative half, which is 1 over x to the power half, which is 1 over root x. That becomes like this, ln y equals negative 2, because that half becomes negative 2 times k 1 over x to the power half plus c. That's what I have done. X is 1 and y is 1. So ln 1 is negative 2k square root of 1 plus c. ln 1 is 0, is negative 2k plus c. That means c is 2k. That's equation 1 I got. Now x is 4 when y is e. Substitute again in that. So I'm writing ln e equals negative 2k, x is 4, square root of 4 plus c. ln e is 1. So therefore 1 equals negative 2k, square root of 4 is 2 plus c. So I'm getting that's 1 equals negative k plus c, right? Now from 1, that's equation 2 now. From 1, c is 2k. So I'm writing, therefore 1 is negative k plus 2k. So k is 1. I got that. Substitute into 1. C is 2 times 1, 2. Therefore C is 2. So I can write ln y, that's the equation I'm using, ln y equals negative 2k, k is 1, so negative 2 over root x plus c, which is 2. So I'm changing into, I have to make y the subject, not ln y the subject. Y is e to the power negative 2 over root x plus 2. You can still further change it, you simplify it, but no need. You could have done, if they say prove that it is that e to the power negative 2, so y is e to the power negative 2 over root x times e to the power 2 y is e squared e to the power negative 2 over root x. Here it's not necessary, it's very unnecessary here. They have said prove, yes. They have said find the equation of expressing past. Fine, it's done. Describe what happens to y as x tends to infinity. So first of all, I will write the equation. Y is e to the power negative 2 over root x. Y is e to the power negative 2 over root x plus 2. All right. So I'm writing as x tends to infinite. Then e to the power negative 2 over root x plus 2 becomes e to the power negative 2 over root infinite plus 2. Now negative 2 over root infinite is 0 because infinite has extremely large number, square root of it is extremely large, and 2 divided by extremely large is 0. So negative 0 is basically 0. So that becomes e to the power 0 plus 2. So that's e squared. So y, as I should have written, as x tends to infinite, y tends to e squared. Next one, number 9 now. With respect to origin O, the vertices of a triangle ABC have position vectors OA 2i plus 5k, OB is 3i plus 2j plus 3k, OC is i plus j plus k. Using a scalar product, show that angle ABC is a right angle. So I'm writing if triangle AB, okay, sorry. I can write angle ABC is a right angle, then BA dot BC is 0, right? So let's try. I should have done AB dot AC, AB dot BC, yes. AB dot, if it is A, B, C, B in the middle, so I try B, A dot BC. So BA is BA dot BC, perfect. So BA is OA minus OB, which is 205 minus 323. 2 minus 3 is negative 1, 0 minus 2 is negative 2, and 5 minus 3 is 2. Now BC. BC is OC minus OB. 1, 1, 1 minus OB is 323. So 1 minus 3 is negative 2, 1 minus 2 is negative 1, 1 minus 3 is negative 2. Let's try the next part. I need BA dot BC. Negative 1, negative 2, 2 dot negative 2, negative 1, negative 2. Negative 1 times negative 2 plus negative 2 times negative 1 plus, it's like that, this times that, then that times that, and then that times that. That's what I'm doing. Plus 2 times negative 2, which is 2 plus 2 minus 4 is 0. Hence, we can say that angle ABC is a right angle or 90 degrees, we can say. Show that the triangle ABC is an isosceles triangle. Let's try with AB and BC that already have. If they are not equal, the moduli of those AB and AC are not equal, then I will try to figure out the third one. But at the moment, let's begin with that. So AB, which is we have calculated already. AB is, or BA. BA is -1, -2, 2. So AB is opposite of that, negative sign of that. So -1 becomes 1, 2, -2. So modulus of AB is square root of 1 squared plus 2 squared -2 squared. Now here, instead of AB, if you have started with BA, it was fine, because modulus of AB is same as modulus of BA. Length remains the same. Let's try the next part. Now we need BC. BC is -2, -1, -2, which is square root of -2 squared plus -1 squared plus -2 squared, which is 9. Root 9 is 3. Now since that's also 3, modulus of AB is same as modulus of BC. We can say that triangle ABC is an isosceles triangle. Let's try the next part. Number C. Find the exact length of the perpendicular from O to the line through B and C. This is what we need. Let me draw and show you. That's point B, for example. That's point C. Now it says for exact length of perpendicular from O. So let's say here somewhere is O. Not necessarily it is the midpoint. Not necessarily. It can be, it cannot be. So that P is the point somewhere on BC where the perpendicular from O can be drawn. So P is the general point on BC. So I can write equation through B and C, which is R is OC, right? So OC plus lambda times CB. That's the general point on line ABC. That's what line BC. Any point. P can be anywhere on the line. So I am drawing. So I can start from O. It's like this. I can go from O to C and then lambda times BC. Why lambda times? Lambda is the it's the scale factor from depending on where the P is, right? So let's try. R is OC. That's 1, 1, 1 plus lambda times CB, 2, 1, 2. Now since OP is perpendicular to BC, let P be the general point on BC. So equation of P, the coordinates of OP, position vector of P, we can say. And CB is 2, 1, 2. Alright, the direction vector of CB is 2, 1, 2. If we had started from, instead of OC, if we had gone from O to B and B to C, then we would have used the direction vector of BC. But because we started from OC, we are going C to B. Hope it makes sense to you. If we started from that and then go there, then we have to use the direction vector of CB. But if we start from O to B and then B to C, then we could have used the direction vector of BC. Doesn't matter where you start from. It will be fine. It will be same. Let's try now. OP dot CB. Why am I doing OP dot CB? Because I know they are perpendicular to each other and the dot product, the scalar product of them would be 0. So that's 1 plus 2 lambda, 1 plus lambda and 1 plus 2 lambda dot 2, 1, 2 is 0. So I'm multiplying it. 2 times 1 plus 2 lambda plus 1 times 1 plus lambda plus 2 times 1 plus 2 lambda is 0. So that gives me 2 plus 4 lambda plus 1 plus lambda plus 2 plus 4 lambda is 0, which is 9 lambda plus 5 is 0. Lambda is negative 5 over 9. So now OP is, I am substituting into the general point for that. That is the general point. I'm substituting there. So OP is 1 plus 2 times negative 5 over 9, 1 minus 5 over 9, and 1 plus 2 times negative 5 over 9, which is negative 1 over 9, 4 over 9, negative 1 over 9. So modulus of OP is, because we have to calculate length of OP, perpendicular length. It says perpendicular, find the exact length of that. So which is, length means modulus, which is square root of negative 1 over 9 squared plus 4 over 9 squared plus negative 1 over 9 squared, which is same as 18 over 81 and 1 over 3 root 2 exact length. All right. If we can try this like that, if your calculator doesn't give exact value, 18 and 81 can be divided by 9. 9 times 2 is 18 and 9 times 9 is 81. So that's square root of 2 on square root of 9, which is root 2 over 3. So 1 over 3 root 2. Let's try the next one. The complex number u is defined by, u is 3i over a plus 2i, where a is real. Express u in the Cartesian form x plus iy, where x and y are in terms of a. So I'm writing u is 3i over a plus 2i. Whenever you have to represent it in the Cartesian form, you have to multiply and divide by the complex conjugate of the denominator. So it's a minus 2i over a minus 2i. Therefore u is 3i times a, 3ai, minus 3i times 2i, negative 6i squared, over a squared minus 2i squared. So u is negative 6i squared becomes negative 6 times negative 1, because I squared is negative 1. So negative 6 times negative 1 is 6 plus 3ai over a squared minus 2 squared times I squared, which is 4i squared. I squared is negative 1, so that is 4i squared. I can write 6 plus 3ai over a squared minus 4 times negative 1. U is 6 plus 3ai over a squared plus 4. Therefore u is 6 over a squared plus 4 and 3a over a squared plus 4i. That's in that form of x plus iy. All right, let's try the next one. Find the exact value of a for which argument of u is 1 over 3 pi. So argument of u star, is 1 over 3 pi. U star, from previous part, it is 6 over a squared plus 4. That is, u is positive, so u star will be negative 3a over a squared plus 4. That's the complex conjugate of u. So argument of u star is same as y. Argument of u star is tan inverse y over x. So I can write that tan inverse negative 3a over a squared plus 4 over 6 over a squared plus 4. I can get rid of the denominator from both sides, so which is same as tan inverse negative 3a over 6 negative a over 2. So, and it's given that argument of u star is 1 over 3 pi. So I'm writing tan inverse negative a over 2 is pi over 3. Sending tan inverse to the other side. So I can write, negative a over 2 is tan pi over 3. Tan pi over 3 is root 3. So negative a over 2 is root 3. A is 2 root 3 negative a. A is negative 2 root 3. Done. Let's try the next part. Let's try the next one. Now the next question is, on a sketch of an argon diagram, shade the region whose points represent the complex number z satisfying the inequalities. Modulus of z minus 2i is less than equals modulus of z minus 2 minus I less than equals 2. Alright, so first of all, let's try modulus of z minus 2i is less than equals modulus of z minus 1 minus I. So that's modulus of z minus 0 plus 2i is less than equals modulus of z minus 1 plus I. That means I have to draw a perpendicular bisector of the points 0 plus 2i and 1 plus I for the first part. That's number 1. For second part, I have modulus of z minus 2 minus I is less than equals 2. So I have to draw modulus of z minus 2 plus I less than equals 2. So that means circle with center 2 plus I and radius 2, and I have to shade inner part. Okay, let's try this. It will be the rough sketch. If I need to alter something, I'll alter according to my need. Now, first point is 0 plus 2i. So that's 1, 2, 3, 4. The other point is 1 plus I. So that's the point. Then I join using dotted line. Join these 2 points because I have to draw perpendicular bisector from them. Alright. Now put my compass tip on 0 plus 2i, which is that point, and then that point. Okay, then I have to draw an arc up using compass and an arc down. Then from compass tip on 1 plus 1i, an arc up, an arc down, and then I join the points passing through them. Alright, it's not exact, I know, but I have tried my best. Alright, next one. Let me try again. Alright, I hope so. It's correct. Next one. Now it says center 0 plus 2i and 2 plus I and radius 2. So 2, that's 1, 2. Two plus I is that's the center, and my radius is 2. So I'm drawing I will try as much as possible to be perfect. I hope it's okay. Alright. Now it says First of all, for part 1, modulus of 0 plus 2i is less than equals 1 plus I. So 1 plus I is more than 0 plus 2i. So that means the perpendicular bisector. Alright, that's fine. Next one. It says now okay, then let me try this. The circle is there. Alright, that's number 2. And z minus 2i is less than equals 1 plus 2i. So 2i is so that is for we are done with that part. Now we have to figure out where is modulus of 2 minus I is less than modulus of 1 plus I. So modulus of 2i, 0 plus 2i, it's from that side, is less than from that. So which means I have to shade the region that side. That's the region I have to shade. Alright. So I have shaded that part. Now it says calculate the least value of argument of z for this point in this region. So argument of z starts from origin. If I say it's that point is the least, and if they have said the greatest, then it was that point was the great. So that was the greatest argument. But they haven't asked greatest, they have asked least. So that's the argument that we are looking for, which is the point 2 plus 3i. So argument of z least is argument of 2 plus 3i. So that's tan inverse 3 over 2, 56.309. So argument of z is least is approximately 56.3. In the radian mode, it was tan inverse 3 over 2 is that's preferable. 3 over 2 is tan inverse 3 over 2, which is in our radian mode. It is 0.983 radians. Let's try the next one.